All right, guys. So, what we're going to do and what we're going to talk about today is statistical machine learning. This is the basis of all data mining techniques or all machine learning techniques that you're going to see in this class. To me, based on interview questions I've heard from major organizations for data scientist positions and for these high level analytics positions, you're gonna need some basic discussion stuff. You're gonna need to understand these concepts. Now, you may never be able to program it. You may never want to program it, and you may never have to. My hope is you don't, because with the jumps we're making, that's what guys like me are for. But with this idea, you still need to understand what these concepts are. So last time we talked about the basic idea of shrinkage with ridge and lasso, right? That's kind of how the flow was gone. It's what we talked about in Module 3. Module 4, we're opening up something a little bit bigger, right? So in this section, we want to create the idea of how these methods are used and what some of the differences that you can see are. Basically, what we're going to start off with is regression. We're going to start, then we're going to move into classification. Then we're going to move into all these different things that you know. The examples I have set up, and I'm going to add to them, and you're going to see more examples than that. But there's, classification with penalized logistic regression. There's, trying to predict continuous variables with penalized Gaussian regression. There's all these different things. But what drives this entire piece are the algorithms. There's two really algorithms we're going to focus on. There's coordinate descent and there's Newton's method. And these are what allow us to calculate these estimators in a big data space. That's what's so important about all this. It's not just, I can create this insight and I can use this. It's about, hey, look, would this thing actually run if I tried it? Guys, there's some methods, as you will see, that will not work in big data settings. But there are some methods that will. You just have to use the right implementation of them. Spark, for instance, it's got lasso and ridge programmed up where you can use it. And Spark, the newer releases 2.0 and beyond, have a lot of the generalized linear models programmed up that weren't there previously because we figured out how to do it quickly and in a way that is scalable long term. So when you're looking at these things, when you're trying to keep these ideas together, keep that in mind as well, because it's something that's extremely important. It's something that you need to know. So the way this is going to work is I'm going to introduce some algorithms to you. You don't need to memorize the algorithms. You don't need to say, I'm an expert in these algorithms. Truth is, there's probably about 10, 12 people on the planet who can claim expertise. The rest of us know the ideas and know how to use the tools to solve a problem, but that's at the PhD level. At the master's level, what you need to understand, if you're getting a master's degree in a big data field, you need to understand what these methods allow you to do and understand the basic concepts behind them. So what's coordinate descent allow you to do? What's Newton's method allow you to do? Well, coordinate descent, one of the things it does is allows us just to have to calculate in like a regression setting, it only allows us to calculate a covariance matrix. Because if we calculate the covariance matrix, what do? Well, we can just hit that covariance matrix. So if you've got 10 terabytes of data, but you can calculate let's say 10 terabytes of data and you've recorded 100 variables, all you have to do is calculate 100 by 100 covariance matrix. That's nothing for a computer. And then calculate that covariance matrix and just keep using it over and over again. That's what the coordinate descent setting is going to allow us to do. Newton's method allows us to approximate equations that are really, really hard to solve. It says, I don't know how to solve that, so what I'm going to do is I'm going to approximate it. And we use that approximation to our advantage and continue to solve, okay? So when I introduce these concepts to you, some of the stuff is concept, some of the stuff isn't. But what we're going to do is we're going to talk about it, how it comes together, and more importantly, how it comes together in this elastic net shrinkage. What the elastic net does, it creates a hybrid between the lasso and ridge. So when you're looking at those things, that's what you're able to approach. That's what you're able to see. So when we get after this stuff, that's what I want you thinking about. That's what I want you talking about. All right, guys, excited to start this one. This is one of my favorite things to talk to high-level master students about. This is fun for me. This is what I work on. But it's more importantly, the tools that you're seeing start to evolve in the field and the machine learning ideas that companies want to implement in their business. What you guys got to understand is a lot of the traditional stuff will break down. It breaks down when P is large, when you have a lot of variables. But it also breaks down in big data spaces. OLS by itself, guys, won't work on 2 terabytes. You've got to implement it in a very sophisticated way. So you've got to think about how it works. You've got to think about what you're doing with it. All right, guys, let me know if you have any questions.